For decades, humanoid robots belonged to science fiction. They appeared in movies as machines that could walk like us, use their hands like us, understand instructions, and work beside human beings. But something has changed. Humanoid robots are beginning to leave research laboratories and enter the world. They are being tested in factories, warehouses, automotive plants, and logistics centers. Machines that once struggled simply to stand upright are now learning to carry objects, move parts, sort materials, and repeat physical tasks for hours at a time. The humanoid robot era is no longer only a prediction. The first pieces of it are all. What makes this moment important is not that engineers can build robots shaped like humans. Researchers have done that for years. The real change is that companies are trying to make these machines useful. A robot performing one impressive demonstration is one thing. A robot working day after day inside a factory is something completely different. So why build robots with 2 legs, 2 arms, and hands? Factories already use robotic arms, and warehouses already use automated machines. The answer is simple. We built the world for ourselves. Doors are positioned for human hands. Stairs are designed for human legs. Shelves are built at human height. Tools are shaped for human fingers. Workstations, handles, switches, and equipment were created with people in mind. Instead of rebuilding every workplace around a completely different machine, engineers are trying another approach. Build the machine to fit the world that already exists. 2 legs can help a robot move through spaces designed for people. 2 arms can reach equipment positioned for human workers. Hands can interact with objects that were never designed for machines. In theory, a humanoid robot could enter an existing workplace without requiring the building to be. Across the robotics industry, companies are developing humanoid machines intended to walk, lift, carry, sort, inspect, and eventually perform more complicated physical tasks. Factories are one of the first places these robots are appearing because the environment is controlled, the floor is predictable, the objects are known, the tasks repeat. There are clear procedures and safety systems. Imagine a worker whose job is to pick up the same component hundreds of times during a shift, carry it several steps, place it on another station, turn around and repeat. To a person, that work can become exhausting. To a robot, repetition is exactly what makes the task attractive. But building a machine that can perform even a simple job reliably is much harder than it looks. Watch a person pick up a box. Your eyes estimate the size. Your brain predicts the weight. Your fingers adjust their grip. Your legs shift your balance. Your arms compensate if the box moves unexpectedly. Most of that happens automatically. A robot has to calculate all of it. It must recognize the object, decide how to approach it, position its hands correctly, apply enough force to hold it, maintain balance, avoid obstacles, and place the object exactly where it belongs. A task humans perform without thinking can become an enormous engineering challenge for a machine. That is one reason early humanoid robots often looked awkward. They walked slowly, they lost balance, their movements seemed cautious and mechanical. They could become confused when something unexpected happened. But those weaknesses are beginning to improve. Motors are becoming more capable, batteries are improving, sensors are becoming smaller and more powerful. Cameras can give robots a detailed view of their surroundings. Computers can process large amounts of information in real time, and artificial intelligence is beginning to change the way robots are. Traditional industrial robots can be extremely precise, but many operate inside carefully controlled environments. A robotic arm might perform the same programmed movement thousands of times. Move here, rotate, grab, return, release, repeat. But if the object moves somewhere unexpected, the robot may need help or new programming. The new goal is flexibility. Developers want robots that can see what is happening around them and adjust. A robot looks at a table. It recognizes a container. It receives an instruction to move that container to a shelf. Its software must connect language, vision, movement, balance, and manipulation into one continuous action. That is where modern artificial intelligence and robotics begin to meet. The goal is no longer to program every tiny movement one instruction at a time. The goal is to create machines capable of learning behaviors. But the real world is rarely simple. There is a huge difference between a robot completing a task once and completing the same task thousands of times without creating. A factory needs reliability. The machine cannot fall over every few hours. It cannot constantly drop materials. It cannot damage expensive products. And most importantly, it cannot create danger for the people working around it. Humans are remarkably adaptable. If someone leaves a box in the wrong place, we step around it. If an object begins to slip, we adjust our grip. If another person suddenly crosses our path, we stop. A robot must recognize those situations quickly enough to respond safely. And the real world is filled with situations engineers cannot predict in advance. A door is left half open. A tool falls onto the floor. Someone walks into the robot's path. Lighting changes. A package is heavier than expected. The machine must understand what happened and decide what to do next. That is why humanoid robots are not suddenly replacing every worker tomorrow. The technology is advancing, but physical reality is difficult. A physical robot has to deal with gravity, friction, weight, balance, battery life, heat, mechanical wear, and the possibility of colliding with something. Every movement has consequences. Then there is the energy problem. Humans are surprisingly efficient. We can walk for hours using energy stored in food. A humanoid robot depends on batteries powerful enough to operate motors, processors, cameras, sensors, and communication systems. More battery can mean more operating time, but more battery also means more weight. And more weight means the motors work harder. Then there is cost. A company does not simply ask whether a humanoid robot can perform a job. It asks whether the robot can perform that job reliably, safely, and cheaply enough to make financial sense. If the machine costs too much, requires constant repairs, or needs engineers nearby to rescue it, the economics begin. That is why the transition will probably happen gradually. First, robots enter places where the work is repetitive and predictable. Factories, warehouses, distribution centers. They may move inventory, deliver parts, unload materials, inspect equipment, or handle jobs that are physically demanding. Then, as the technology improves, the tasks may become more complicated. Robots could work in environments that are too hot, too cold, contaminated, or dangerous for people. They could assist with maintenance, move heavy equipment, or help businesses perform jobs that are difficult to staff. Eventually, humanoid robots could move beyond industrial settings. That is when the story becomes much bigger. Imagine a robot inside a hospital, moving supplies through hallways. A robot in a hotel carrying equipment. A machine helping technicians in a repair facility. A robot stocking shelves after a store closes. Or eventually, a machine inside your home performing ordinary tasks. Those applications are much harder because homes are unpredictable. Factories can be organized. Homes are messy. Objects move constantly. Pets run through rooms. Children leave toys on floors. Furniture changes position. People give unclear instructions. A robot that works perfectly in a factory may struggle inside an ordinary kitchen. But if engineers solve those problems, humanoid robots could become one of the most important technologies of this century. And that leads to the question almost everyone asks. What happens to human jobs? The answer is complicated. Automation has been changing work for generations. Machines replaced some jobs, transformed others, and created entirely new industries. Humanoid robots could follow the same pattern. The first tasks likely to attract automation are those that are repetitive, physically demanding, dangerous, or difficult to staff. That could reduce the need for people to perform certain kinds of manual work. But robots also require manufacturing, programming, maintenance, supervision, repair, training, safety management, and new infrastructure. Some jobs may disappear, some may change. New jobs may emerge. Safety may matter more than anything else. A powerful machine walking near people needs emergency stops, collision detection, controlled speeds, reliable sensors, and clear operating rules. So the future of humanoid robotics depends not only on intelligence, it depends on trust. Workers need to trust that the machine will stop when it should. Companies need to trust that it can perform reliably. Regulators need to understand how these systems should operate. And the public needs to understand what happens when humans and robots begin sharing the same spaces. We are still early in that process. Many humanoid robots receiving attention today are still being tested and improved. Battery life remains a challenge. Reliability remains a challenge. Cost remains a challenge. Safety remains a challenge. And nobody knows exactly how quickly these machines will become common. But one thing has changed. The question is no longer whether engineers can build a humanoid robot. They can. The question is whether they can build one useful enough, reliable enough, safe enough, and affordable enough to become ordinary. Because technological revolutions rarely arrive in one dramatic moment. Instead, the technology appears quietly. One robot enters one factory, then another enters a warehouse. A company orders more. A new model becomes faster. Another becomes cheaper. Another learns more tasks. Eventually, people look around and realize that something once considered extraordinary has become normal. Technology becomes transformative when it stops feeling extraordinary. Humanoid robots may be approaching the beginning of that transition. Not because millions of them are suddenly walking through our cities, they are not. Not because human workers are disappearing overnight, they are not. But because machines are beginning to enter environments that were designed entirely around the human body. And once a machine can operate inside our world without requiring us to rebuild everything around it, the possibilities become much larger. Today, the robot may carry a container across a factory floor. Tomorrow, it may perform 10 different tasks. Later, perhaps hundreds. The real revolution may not happen when robots become stronger than us or faster than us. It may happen when we stop noticing them. When seeing a humanoid robot carrying supplies through a building feels no stranger than watching an elevator move between floors. That future may still be years away, but for the first time, we can see a path leading toward it. The machines are learning to walk. They are learning to see. They are learning to use their hands. And increasingly, they are learning how to work inside the world we built for ourselves. Humanoid robots are not arriving someday. They are arriving piece by piece, factory by factory, task by task. And they may be entering our world much faster than anyone expected.